So question 149. This equation that we're solving here is one that I think only numerical methods can be used. I don't think it can be solved analytically. So numerical methods have to be used to solve an equation like this. So the one that we're using in this example is the iteration method. So in order to show that there is a root in the interval 2.7, 2.8, we need to find the value of f of x when x is 2.7 and the value of f of x when x is 2.8. So that's f of 2.7 and f of 2.8. So f of 2.7 is that small number, positive number. You may have had trouble if you didn't use radians. So we see that when we use radians, we get a change of sign there between 2.7 and 2.8. But that's not quite enough. We also need to make a statement about continuity as well, saying that the curve is continuous over this interval 2.7 to 2.8. So that's the answer then. The change of sign and continuity indicates the root lies in that interval. So now we've got to show that the equation f of x equals 0 can be rearranged into this form here. So that equation there is f of x equals 0. If I take the minus 3x over to the other side, I get that. And then divide by 3, I get x is 2/3 cos x plus 10/3. So that tells me that the value of a is 2/3 and the value of b is 10/3. And I have to write those down to get the answer because the question asks me to state the values of a and b. Okay, so now we need to use an iterative formula based on that rearrangement, this rearrangement here. So that's the rearrangement. We convert that into an iterative formula by putting an xn there and an xn plus 1 there. So that's our iterative formula now. Now we're going to use that with an initial value of x0 being equal to 2.7. And when we do that, we put that into there, 2.7 into there, we'll get x1. So x1 is 2/3 cos x0 plus 10.3. So we put the 2.7 in, and then we get this value for x1, again using radians. And this number is rounded to 3 decimal places. But in the next calculation, I use an unrounded version of that value to give me the value of x2, and then an unrounded version of that number to give me x3. So those are the values of x1, x2, and x3 to 3 decimal places. But I haven't yet finished because I've got to show that the root is 2.724. correct to 3 decimal places. So thinking of the number line here, 2.724 to 3 decimal places. The next number on the number line which is correct to 3 decimal places, 2.725, and the one before is 2.723. So if I want to show that the root is 2.724, correct to 3 decimal places, I need to show that it's closer than it is closer to 2.724 than it is to either of these two numbers. I have to show that the root lies somewhere in that interval. So these numbers here, 2.7235 and 2.7245. So f of 2.7235 is a small positive number. F of 2.7245 is a small negative number. And once again, mentioning the continuity angle as well says that the root must lie between those two numbers, and therefore the root is 2.724, correct to 3 decimal places. So numerical methods, numbers all over the place, but that's the point. Okay,